Let's practice evaluating trig functions using reference angles together. For number 1, we have cosine of 4 pi over 3. So let's start by looking at a coordinate plane and figure out where this angle would be. So 4 pi over 3, well, that's going to start from 0 radians over here. Now 3 pi over 3 would be 180 degrees. That would be right over here. So this would be 3 over 3. So we need to go an extra third, and the extra third would bring us somewhere around here, right? So let's go ahead and see where that would be. I think it would be roughly right over here. Okay, if I was just to make a rough estimate, so I think this right over here, from here to here, this would be this angle measure theta of 4 pi over 3. Now this angle over here is going to be the reference angle. Now remember, that is always going to be in relation to the x-axis. So if we take a look right over here, this is where that reference angle is, and we went pi over 3 past the x-axis, so this is going to be pi over 3. That's the reference angle. And if you're just curious about what that is in degrees, if you're just getting used to that maybe, that's going to be 60 degrees. That's the same thing as pi over 3. Now my recommendation is to take this angle that we have here of pi over 3 and just make a triangle on the side. And so drawing this reference triangle or reference angle of a 30, 60, 90 triangle, which is a special right triangle, we want to keep in mind we know the ratios of our side lengths here of 30, 60, 90 triangles is going to be 1 for the shortest side, but because we're in quadrant 3 here, it's going to be -1. And then the longest side is always going to be 2, and the hypotenuse is always positive. And then this medium side is always going to be the square root of 3. But because we are in quadrant 3, that's also going to be negative, right? So if we plotted this point down here, this is going to be -1 comma negative root 3. So anything in quadrant 3 is going to be negative comma negative. Okay, so this is important to know just because if we're going to find cosine of this 4 pi over 3, we have to use this reference angle of 60 degrees. If we're using cosine, try to remember cosine is going to be adjacent over the hypotenuse, also known as the x value over the r value or the hypotenuse. Okay, so for finding cosine here, we're going to go ahead and say this is going to be the ratio of the adjacent over the hypotenuse, which is -1 over 2. And that's, again, that can simplify down to being -1/2. So cosine of 4 pi over 3 is going to be equal to -1/2. Let's check out number 2. For number 2, we have this another angle measure and a different trig function. We have tangent of -210 degrees. Let's start by putting this on the coordinate plane. So starting from the positive x-axis where 0 degrees is going to be, we are going to be moving clockwise this time. So this is going to be 90 plus another 90, that's 180, and we need to go 30 degrees more. So this -210 degrees is going to be 30 degrees past 180, so maybe something like this. Okay, just a rough estimate there. And so this -210 degrees is going to be going clockwise this time because it's negative. And so that's going to be our theta. Theta is going to be -210 degrees. As for our reference angle, that is going to be the angle formed relative to the x-axis. So this angle that is formed right over here, this is going to be our reference angle. And so inside there, we're going to have, let's see, that's 30 degrees away from the horizontal. So this is going to be a 30-degree reference angle. And in radians, just to practice, this would be pi over 6. But we're not going to use that this time, but maybe that's just helpful to know. From here, we can go ahead and draw a reference triangle. And this is going to be a right triangle. That's going to be a 30, 60, 90. And let's just go ahead on the right side and replicate that with a little bit cleaner picture here. And this is a 30, 60, 90 triangle. So we are in quadrant 2 here. So the shortest side of a 30, 60, 90 is going to be 1. That's going to be the y value, so it's going to be positive. The longest side is always going to be 2, and it's always going to be positive. And now for the x value, that is going to be the medium side. Now it's root 3, but because we are in quadrant 2, it's going to be negative. So if we plot this end point of the triangle over here, that's going to be plotted a negative x value and a positive y value. So that negative root 3 is negative, and the 1 is positive. Now, if we're taking tangent of this 30 degrees, tangent is going to be the ratio of y to x, or it's going to be opposite over adjacent, whichever one works better for you. So that's going to be 1 over this negative root 3. So we're going to say it's going to be 1 over this negative root 3. And what you can do here is we can rationalize the denominator because we don't want a radical in the denominator. So we're going to multiply by root 3 over root 3. And if we do that, we're just going to end up with negative root 3 on top. And then on the bottom, root 3 times root 3 is just going to be 3. So our final ratio here is going to be this negative root 3 over 3. That's what tangent of negative 210 degrees is. Here's number 3. For number 3, we have cosecant of this 11 pi over 4. Let's start by putting this on a coordinate plane. So we have radians here. We're going to start from the positive x-axis. Here's 0 radians. And let's see which way we are going. We're going counterclockwise because it's positive. Now 8 pi over 4 is going to be a full circle. That's going to be 8 pi over 4. But we're going to 11 pi over 4, so we still need to go 3 over 4 pi, or 3/4, right? So we're not going to go a whole pi, but this is going to be a half plus another quarter. So half plus a quarter is going to be 3/4. So we're going to end up in quadrant 2 here. So over in quadrant 2, let's go ahead and draw halfway across this quadrant. With a positive angle, we are going counterclockwise, so that's going to be a full cycle plus another half plus another quarter pi. So we end up over here where theta is equal to that 11 pi over 4. Now that we know where this 11 pi over 4 is, we can go ahead and sketch our reference angle, which is in reference to the x-axis. So there's the x-axis, and here is where our terminal angle is. This is our reference angle, and that is going to be pi over 4. This is also known as 45 degrees, if that is helpful to know as well. Okay. So just like we did in the last couple examples, we're going to go ahead and create a right triangle to help us figure out what is going on here, but it's not going to be a 30, 60, 90 triangle this time. It's going to be a 45, 45, 90 triangle, which is another special triangle. All right, so we have a 45, 45, 90 triangle here. We are in quadrant 2, so we should have a negative x and a positive y. Now for all 45, 45, 90 triangles, we have a ratio of 1 to 1 to root 2, just because it's an isosceles right triangle. Now we are in the x direction be a negative 1, in the y direction it's going to be a positive 1, and the hypotenuse is going to always be positive. That's going to be root 2. Okay, so if we are finding this to be our reference angle of 45 degrees, we have cosecant here, which is the reciprocal of sine. Now we want to think about what is sine of this 45 degrees. I'm going to put that on the side here. If we were just doing sine of this 45 degrees, or sine of this pi over 4, which is just dealing with radians here, sine would be opposite over hypotenuse, or the y over the r value. That's going to be 1 over root 2. So that's what sine of that angle would be, 1 over root 2. But because we are finding cosecant here, that's going to be the reciprocal of this. It's actually going to be flipped upside down. We're writing the reciprocal, so that's actually going to be root 2 over 1. And that's just going to simplify down to just being root 2. So that's what cosecant of this 11 pi over 4 is going to be equal to. Here's number 4. For number 4, we have cosine of negative 120 degrees. Let's put this on a coordinate plane to figure out where this is located so we can figure out the reference angle. So here is the positive x, that's going to be 0 degrees. Because we have a negative angle, let's go clockwise this time. So we're going to move, let's see, this is 90 when we reach this part, and that's going to go another 30. So we're just not going to go too far here. We're going to end up in quadrant 3. So we're going to put our terminal side maybe something like this. Okay, so this negative 120 degrees, that's going to go clockwise just like this. And so that's theta, which is negative 120 degrees. And then for our reference angle, that's going to be in reference to the x-axis. So going just like this is going to be our reference angle. Looks like we're going to be 60 degrees away from the x-axis. So we're going to go ahead and sketch a 30, 60, 90 triangle. That is going to be over in this quadrant 3, just like this. Let's go ahead and sketch that on the side. Here's our 30, 60, 90 triangle. Hopefully we're getting a little better with our ratios. We are in quadrant 3, so we should have a negative x and a negative y value. So our shortest side should be 1, but it's going to be negative 1 this time because we're in quadrant 3. Our longest side is always positive, the hypotenuse, or the radius of a circle. And let's also know that our medium side is going to be root 3, but because we're in quadrant 3, it's going to be a negative root 3. So again, this is our x value, and this is our y value coming down. So that's x comma y, which is why this point is down here in quadrant 3. Okay. Now we're figuring what cosine is of this 60 degrees. Now cosine is going to be adjacent over hypotenuse, so it's going to be negative 1 over 2, or you can also think about it as x over r. So we're going to go ahead and say this is going to be negative 1 over 2, which we're going to just simplify and say this is going to be negative 1/2. So that is going to be the ratio of cosine of negative 120 degrees. Here's number 5. For number 5, we have sine of 7 pi over 4. Now let's start by putting this on a coordinate plane to see where this angle is going to lie. So here is our initial side here. Now 7 pi over 4 is positive, so let's move in that counterclockwise direction. Now a full pi would be over here, that's 4 over 4. Another half would bring you to 6 over 4. 7 over 4 is going to be half way into this fourth quadrant here. So I'm going to go ahead and sketch this as halfway into here, maybe something like this roughly. Okay, so if we're going to go ahead and see where that 7 pi over 4 is, that is in this direction, where theta is 7 pi over 4, which is just a quarter shy of a full circle here, so that's 315 degrees. Now what about the reference angle? The reference angle is going to be located over here. It's this acute angle that is formed in relation to the x-axis, so this right here would form my reference angle, and I think it's going to be pi over 4 away from the x-axis, or also known as 45 degrees. Notice how we can draw an isosceles right triangle, which is a 45, 45, 90 right triangle. Let's go ahead and do that on the side and use those ratios of their side lengths to figure out what sine of 7 pi over 4 is. All right, so we have our 45, 45, 90 triangle. We have a ratio of 1 to 1 to root 2. Now for the x value here, this is going to be a positive 1. For the y value, though, it's going to be negative 1. Because if we plot this point down here in quadrant 4, we have to go to the right 1 and we have to go down 1, right? And for the radius, or the hypotenuse rather, here in this case, this is going to be just root 2. That's always going to be positive. Now if we're taking sine of this 45 degree reference angle, that's going to be opposite over hypotenuse, or the y value over the r value, so that's going to be negative 1 over this root 2. So sine of 7 pi over 4 is going to be negative 1 over this root 2. Now let's go ahead and rationalize the denominator so we don't have a radical down there, so we can multiply by root 2 over root 2, which is just equivalent to 1. We're going to get negative root 2 on top, and on the denominator, root 2 times root 2 is just 2. So we can just say this would be negative root 2 over 2 would be the ratio for what sine of 7 pi over 4 would be equal to. For number 6, let's take a look at what cotangent of negative 135 degrees is. Now this is a reciprocal function, so maybe we'll look at tangent of that negative 135 first. All right, so plotting this, let's go ahead and put our initial side. This is going to be 0 degrees. Now if we're moving to negative 135, let's move clockwise. So that's moving this way, so it's not going to make it to 180. So right in the middle of this box, I believe, we're going to stop. So I'm going to go ahead and put our terminal side halfway through this box here. And so this angle right over here, that's the angle we're dealing with, and that's negative 135 degrees. Now, as for the reference angle, that's going to be located right over here. So that and here, what angle does that form? Looks like that's going to be the reference angle, and it looks like it's 45 degrees away from the x-axis. And again, if you want to see that in radians, sometimes I'm remembering to write this, but I'm going to write it as pi over 4. So pi over 2 is 90 degrees, so pi over 4 is 45 degrees. Now, we create a 45, 45, 90 triangle here, which is an isosceles right triangle. Let's go ahead and sketch this on the right so we can deal with this a little bit more clearly. So here's that 45, 45, 90 right triangle, and we're in quadrant 3 here, so we should have a negative x and a negative y. So we're going to have this be negative 1, and then a positive root 2. Because we are in quadrant 3, the x and y need to be negative, and hypotenuse is always going to be positive, right? So tangent of this 45, that would be opposite over adjacent, which would be negative 1 over negative 1. It's also the ratio of the y to the x value, so that would be still negative 1 over negative 1. So if we know that tangent of 45 degrees here is going to be just positive 1 because it's negative 1 over negative 1, then cotangent of this is just going to be the same thing, right? So cotangent of 45 would be the reciprocal of 1, which is still going to equal 1. So cotangent of negative 135, that's going to equal positive 1. Okay, so hopefully that makes sense, but the reciprocal of 1 is still going to be 1. Here's number 7. For this one, we have tangent of 11 pi over 6. Let's go ahead and plot this down. So here is going to be 0 pi. So moving in a counterclockwise direction, this is going to be 6 over 6. That's going to be a full 180. Plus another half a pi, that's 3 over 6. So that brings us to 9 over 6. We still have to move 2 over 6, which is going to be a third. So we're not going to be quite making a full circle. We're going to be 1/6 shy of a full 12 pi over 6 or a full 360 degrees. So it looks like we're going to have something maybe along the lines of this over here. So this angle measure of 11 pi over 6 is going all the way counterclockwise this way. So there's the 11 pi over 6. As for the reference angle, that's going to be formed by these two rays right here. So this right here is going to be the reference angle, and I believe that's just going to be pi over 6 because that's how far away we are from the x-axis, and that's also known as 30 degrees. Hopefully you can see that we're going to have a 30, 60, 90 triangle built in right over here. Let's go ahead and redraw that to the right where we have a little bit more space to work with. All right, so we're dealing with a 30, 60, 90 triangle. The ratio here of the shortest side is going to be 1 because we're down in quadrant 4. This is a y value, so it's -1. The longest side is going to be 2. It's always going to be positive if it's the diagonal. And then we're going to have a positive x value of positive √3, right? So if this is the point in this quadrant, we plot it by moving √3 to the right and by moving 1 down. So it's positive x, negative y. Now we're finding tangent here. Tangent is going to be opposite over adjacent, so tangent of 30 is going to be this -1 over √3, or it's also the ratio of y over x, which would still be this -1 over √3. So let's go ahead and write that as -1 over √3 as our ratio. Now let's go ahead and rationalize the denominator since we have an irrational denominator right now. We can multiply it by √3 over √3, which is really just equal to 1. And that'll be -√3 over 3. So this would be what tangent of 11 pi over 6 is equal to. Here's one final example. For this one, we are going to go ahead and see if we can figure out what secant of -780 is equal to. Here's the initial side over at 0 degrees. Now it's negative, so we're going to be moving in a clockwise direction. So if we go in a full circle here, that's going to bring us to 360. If we go in another full circle, that's going to bring us to 720. And we have to go another 60 degrees to get to 780, right? So we're going to move until we hit maybe right about here. So this would be 60 degrees past 720. We're going to still be in quadrant 4. So I'm going to go ahead and write this moving roughly here. Seems just about right. So sketching this out, we're going clockwise, so that's going to be 360 if we make a full circle, 720 for another full circle, and then another 60 to make it over here. So theta would be -780 degrees, and if we want to see what the reference angle is going to be, that's going to be this angle formed right over here. Looks like we went 60 degrees past the horizontal earlier, so we know that this reference angle is going to be 60 degrees. And the special right triangle we're going to be dealing with here is going to be a 30, 60, 90 triangle, where our reference angle is going to be 60 degrees. So let's go ahead and write that to the side. We're over here in quadrant 4, so the x value is going to be +1. Our hypotenuse is going to be 2. It's going to be positive, but our y value, the opposite side to 60, is going to be -√3 since we're going down. And so these are going to be the side lengths here. And so if we take secant, that's actually the reciprocal of cosine. So maybe let's think about cosine first. So cosine of 60 would be adjacent over hypotenuse. So that's going to be 1 over 2, also known as the x value over the r value. So maybe I'll write that down and say, okay, well, cosine of this 60 degrees, that's going to be 1 over 2. So what about secant? Now, secant is going to be the reciprocal of that. So let's go ahead and say, well, secant of 60 degrees, that's going to be the reciprocal, so that's going to be 2. So if secant of that 60 degrees is going to be 2 in this quadrant, then secant of -780, which is in the same location, that is also going to be 2. All right, so that's going to be the ratio here of 2 to 1, or just 2 to simplify it down. And so secant of -780 is equal to 2. So there you have 8 different examples of evaluating each of these trig functions with some angles in degrees, some in radians, using some of these reference angles and using 30, 60, 90 and 45, 45, 90 right triangles and using their ratios in each of the quadrants to figure out what all the ratios are. So if you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or a friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.